inflow, outflow. And that steers you from the anterior to the posterior deflection. Again, stabilizer will steer you aortic when you push it in, and when you pull it out, it will come posterior. And again, this demonstrates in the top left here, pushing in, we go to the aortic valve. That's why we don't say anterior, because we're not technically going anterior. It's not. Everybody will know where you're going if you say it, but we try and get the vernacular correct, and then pulling the guide out brings you posterior, clocking septal, counterclocking steerable guide catheter, lateral. So now you've got the echo image to look at that. So hopefully you've got the echo image to look at that.
Flipping to the previous.
Yeah, it should play, but we'll see it in a moment. So, the objective again in these views to get the actual pathway, the actual alignment towards the RV apex. The X-plane sample volume, if you leave that switched on, that white line, that's generally the pathway you want your clip to go. So when you see it deviating when you're checking your trajectory, you've got a good visualization of then correcting it before you go below the valve. We want the green plane, any deviation, too much flex, too little flex. The RV inflow, again, we want the clip axial to the apex. If we're going septally, maybe we just counterclock, or if we're too lateral, we clockwise the steerable guide catheter. Here they're just they're going to start flexing down, and again, we need to be cautious about when we're flexing down, because depending on where your guide is orientated, when you add your flex, it can lift the clip up into the intra-atrial septum. If it's lifting up into the intra-atrial septum, counterclock your guide, and then it will come away from the intra-atrial septum, and then you should then be able to steer down quite accurately. Just remember, if you've got your negative on your guide and you're clocking and counterclocking your guide, all you're doing is turning it in a circle. So it doesn't look like it's moving at all, except round and round. In that case, take some of the negative off to go back to neutral. And when you see the curve, then you'll actually identify the steering of the steerable guide catheter. Again, this is just demonstrating the flex and extend and what you're trying to achieve as you add your flex on, coming anterior to the posterior side. Once you've got the axiality, then we can position it using the stabilizer. Likewise, you would be doing that flexing down with your X-plane, so you would have your RV inflow in your second image. So as you flex down, you'll then be able to see the direction of the clip in the right atrium, and you can count clockwise or counterclockwise to bring you back to the coaptation plane. In this example, you can see the shaft of the clip running parallel to the intra-atrial septum and pointing laterally. Clocking your guide won't change that. So this is where we would add the L knob on to bring you away from the septum, takes you more laterally but brings you more centrally, and clockwise your clip back to the coaptation point, then your axial pathway becomes more predictable and more planned. I'll just go out and come back in. The S and L knob of being able to pull away from the intra-atrial septum and then correcting it by using the steerable guide catheter. But in the unusual anatomies, maybe the shaft is coming in very laterally and you need to add some S knob on to bring it closer to the septum. So it pretty much overcomes most of the challenges that we face in all the anatomies. Once we've got the axial alignment correct,
S knob you said if we give plus the
S knob is if you're a long way from the introtracheal septum pointing towards the ventricular septum. Then it will lift you up towards the septum, and then you can counterclockwise the guide a little bit to bring you back to the coaptation of the leaflets. It's not often you need the S knob, but it can be useful. Once we've got the axial alignment correct, in goes aortic and then out with the stabilizer, so it comes posterior. So this is just the losing and gaining height. So if we want to gain height, negative on the guide will lift us up, and then we need to put flex to bring us back down to the actual alignment of the valve. Likewise, if we're losing height, we need to lose height, you put plus on, and then you will need to take some flex off. Multiplanar reconstruction, when it's good, it's good. More commonly, it's average, and not uncommonly, it's just suboptimal that you can't really see what you're looking at.
I agree.
This is good, but understanding the imaging becomes important. And part of that is obviously we can see the aorta here, but if you can't, then it becomes quite difficult to understand exactly how the images are orientated. And that becomes where you acquire your image from as well. Mid-esophageal window inflow-outflow should be the standard 3D acquisition for the data set to then orientate the images, inflow-outflow, RV inflow, transgastric, and then your 3D. But again, depending on the echo experience, it can take a long time for them to align. If you're trying to grasp and the planes aren't lined up, it can be a bit challenging to do what you're trying to do. This is just opening up the clip. You should be familiar with opening up the clip. Once you've opened up the clip to 180, it's a good opportunity to then test your gripper, tactile marker, understand which gripper's septal and lateral. And then we can start to consider about looking at the perpendicularity of the clip. Again, just an example of having too much flex on or having the correct flex on. And again, it's important, and I think sometimes we underestimate how important that axial pathway is. And from your mitral understanding, you'll realise that, again, if you have too much M knob or not enough, you go into the caudal regions, and what we're trying to do is minimise that. Now, when you rotate your clip to get the clock or counterclockwise and the perpendicularity correct, on the tricuspid, there is more of a lateral or septal swing as well. So your clip will rotate. When you're clockwise, it rotates septally. When you counterclock, it comes anteriorly. So there will be some adjustment clockwise or counterclockwise to bring you back to the coaptation plane when you're rotating. Translating the torque out is the same as your mitrals. Using fluoro, if you use fluoro to go below the valve, you'll align your C arm to see the side of the clip. As you advance into the ventricle, if the clip arms appear, you know it's rotating, so you can quickly correct it before you go too deep. The grasping of the leaflets is the assessment of the way we grasp the leaflets and how we assess the leaflet insertion are very similar to your mitral. The imaging is key to understanding the leaflets coming over the clip and into the clip. This should play. This is a bit better image anyway. Sorry, go back. So what we try to encourage is the standard orientation. So RV inflow view, 2 clip arms and seeing the leaflets. You retract back up, sit the leaflets on the clips, and then you put the grippers down and close the clip. Your multiplanar reconstruction can provide that information for you, but the reality is when you're grasping, all you want is the RV inflow view. We don't need the inflow-outflow, don't necessarily need the transgastric or 3D. So sometimes there's a lot of information your eye gets attracted to when really you just want this one image. So if the image is good multiplanar reconstruction, get Echo to just zoom in on this image. So you just have the one image in a large scale, so you can really appreciate what you're trying to visualize and do from an Echo point of view. Again, using the transgastric view for grasping can be very valuable. It's a very technically challenging view to grasp your leaflets, but it's a very easy view when you understand what you're trying to do. If you're learning this therapy, we start with a standard inflow view, but once you get more understanding, we start to introduce the transgastric view, because when it's good, it's easy. And I say that because if you visualize every component of what you're trying to do, you can simplify all aspects of post assessment as well. I think even the here we are. So again,
The transgastric will actually tell us whether we are in mid or central or.
yes, it shows you where you're positioned.
So that will make it one step above accurate.
Well,
Right.
exactly. The accuracy is there. The visualization of the leaflets on the clip arms, you can see. The challenge with transgastric is sometimes you can't understand how much leaflets on the clip arms.
Okay.
So that would be, if you do a transgastric grasp and you're not sure, that's where you go back up top to then look at leaflet insertion and leaflet length captured. I think my laptop's saying it's time to wind up. It's giving up, guys.
Give it a pen.
It'll kick in a minute, I'm sure. These slides are always the best slides you see in any presentation. The reality, of course, is never this easy.
Yes, it's
So, but understanding what we're looking at, the clearer we get to see the information, the more confidence we have with what we're seeing and how we then proceed from there. And that's based on the quality of echo that you're going to get. So this is the value of ice if you have it. You know, they've got 3D ice here, but the reality is all you're looking for when you've got an ice catheter down, the clip arms and the leaflets. You're not using your ice to steer with, so you don't need to know what image plane you're looking at. You're just looking for the anatomy in the clip. So that it can be, in some cases, a valuable addition to the imaging component of this. Assessing the leaflets, as I say, the same assessment as you would do with your mitral, explaining, look at the RV inflow, leaflets coming over the clip arm into the clip with some restriction. Again, visually, there's more redundancy outside the clip with your tricuspids. So understanding that will help you be more confident you've got sufficient leaflet in the clip. Here we can see the leaflet's restricted. I think the importance for NPR now is you can manipulate the image planes into the clip and out of the clip. And I think that's the key. Trying to understand how much are we measuring leaflets. The problem is measuring at the exact spots that you measured the length of the leaflet. And I think that you've only got to be 1 or 2 millimeters incorrect and you think you haven't got enough leaflet. So the key will be bringing your X-plane out of the clip to see the leaflets, only the leaflets here. Then you measure the leaflets. Then when you bring the X-plane back into the clip, you'll be able to measure exactly to the points of what leaflet is outside of the clip arm. And that will be the accurate way of assessing how much we've grasped. Transgastric view, we want to see the leaflets coming over the clip into the body of the clip, and then when the grippers go down, you see that anchored on the clip arms. But the important part of the transgastric view is when you've lowered your grippers, you close your clip in this view. Because then what you'll do is you'll see the leaflet tips come together as you close your clip, and that will give you a good understanding that you've grasped both leaflets.